Look up at the night sky and you are gazing into the past. The light from some stars began its journey millions of years ago, crossing the cold, silent void to reach your eyes. You are witnessing ancient echoes of the universe, a reminder that time in space moves at a pace beyond human comprehension. In space, there is no air, no medium for sound to travel. If you screamed, the void would swallow your voice completely. It is a universe of silence where explosions bloom in perfect quiet and planets drift in a soundless ballet. The sun is not still. It breathes in waves of plasma, sending ripples of energy across the solar system. Its solar winds shape the tails of comets, and its heartbeat can be felt even on the distant edges of interstellar space. When light is born in the sun's core, it begins a slow, staggering journey. Trapped in a dance of endless collisions, it takes thousands, sometimes even 1,000,000 years, just to reach the sun's surface. Yet once free, it speeds through the cosmos, reaching Earth in just 8 minutes. The Milky Way is not just a collection of stars. It is a flowing river of light, stretching 100,000 light-years across. Within it, billions of suns burn, each surrounded by unseen worlds, whispering their secrets across the dark expanse. Some stars you see tonight no longer exist. Their light, traveling for thousands or even millions of years, still reaches us, painting the sky with ghostly memories of a cosmos that has already changed. Black holes are the ultimate stillness, where even time itself hesitates. They do not pull, they bend, twist, and fold space around them. Anything that drifts too close is lost, swallowed into an unseen abyss where the laws of physics dissolve. If you could stand on Venus, you would be bathed in golden light, but also crushed under an atmosphere 90 times heavier than Earth's. The air is thick with toxic clouds, and rain falls as sulfuric acid. Yet beyond the storms, Venus once may have had oceans, whispering of a time when it was not so different from Earth. When a massive star dies, it does not simply fade. It explodes in a breathtaking supernova, outshining entire galaxies for a brief moment. In its last breath, it forges gold, silver, and the iron in your blood, scattering these elements across the universe to one day become part of new worlds. The darkness of space is not empty, it is alive with invisible forces. Gravity tugs at galaxies like an unseen hand, and dark matter, though invisible, outweighs everything we can see. The cosmos is stitched together by things we cannot yet fully understand. Close your eyes. Imagine you are drifting, weightless, beyond the reach of Earth. The air is silent, the stars scattered like distant lanterns in an infinite sea. You are no longer bound by time, no longer tethered to the world below. You pass a dying star, its last breath painting the darkness with ribbons of light. Fragments of its existence scatter into space, some destined to become part of new planets, new lives, new stories. Perhaps one day they will become part of you. Farther still, you find yourself near a black hole, a sleeping giant in the void. Time bends as you approach, stretching moments into eternity. The universe beyond seems frozen, yet to an outside observer you would vanish in an instant. The pull is irresistible, but just before you fall beyond the event horizon, you drift away, carried by the currents of space itself. In the distance, the Milky Way swirls like a luminous tide, its billions of stars whispering secrets to one another. Somewhere, on a small blue world, a person stands beneath the night sky, looking up, perhaps at this very moment, wondering what lies beyond. And so, the universe continues, unfolding in endless cycles, a story written in light, gravity, and time. The universe is not still, it stretches and grows, expanding faster than the speed of light. Galaxies drift apart like cosmic islands lost in an endless ocean. One day, distant galaxies will be so far away that their light may never reach us again. Though space itself is a vacuum, astronauts returning from spacewalks describe a distinct scent on their suits, like burning metal, gunpowder, or even seared steak. It is the scent of dying stars, of cosmic radiation, of a universe constantly in motion. Beneath the icy shell of Europa, one of Jupiter's moons, an ocean deeper than Earth's entire seafloor stretches in the dark. It is warmed by tidal forces moving and shifting beneath miles of ice. Scientists believe that somewhere in its depths, life may stir, hidden from the light but alive in the abyss. The moon is slowly drifting away from Earth, moving about 1.5 inches farther each year. Long ago it was much closer, and its glow filled the night sky with a silver radiance far brighter than today. Millions of years from now, a future skywatcher may look up and find the moon smaller, fainter, an echo of what once was. Far beyond our solar system, a planet called 55 Cancri E glows with an eerie brilliance. This world is so rich in carbon and so pressurized that scientists believe much of it may be made of pure diamond, a gem the size of Earth spinning in the darkness, unseen but real. Drift deeper into the endless night. The stars hum in silent harmonies, their light crossing centuries just to reach you. Somewhere a comet wanders, tracing its frozen path around the sun, leaving a shimmering trail in its wake. You float past Saturn, where golden rings whisper secrets in icy particles. Beyond Neptune, the darkness grows thicker, and time itself seems to slow. Out here, past the planets, past the known, the Oort cloud swirls like a forgotten dream, a realm of sleeping comets waiting for a call that may never come. And farther still, past the reach of the sun's final breath, Voyager drifts, carrying the voices of Earth into the unknown. It will never return. It will never look back. But its journey, like yours, is endless. Launched in 1977, Voyager 1 carries a golden record, a time capsule of Earth's sounds, music and greetings in 55 languages. It has traveled so far that it now drifts in interstellar space, a lonely messenger from a distant world. In the Boomerang Nebula, temperatures fall to minus 457.7 degrees Fahrenheit, just a fraction above absolute zero. Here, atoms barely move, frozen in near-perfect stillness. It is the closest place in the universe to true emptiness, a cosmic whisper against the roar of existence. At the heart of our galaxy lies Sagittarius A*, a supermassive black hole. Around it, stars whirl in an eternal dance, drawn by invisible forces. Scientists have detected radio waves emanating from this core, deep, resonant notes that vibrate like a song no one can hear. Though it now sleeps beneath a blanket of dust, the moon was once alive with fire. Ancient volcanoes erupted across its surface, painting its grey plains with rivers of lava. The echoes of that heat remain, hidden beneath the craters and ridges we see today. Floating 12 billion light-years away, a massive cloud of water vapor surrounds a quasar, containing 140 trillion times the amount of water in Earth's oceans. It is the largest reservoir of water ever found, drifting silently in the void. Imagine you are weightless, a traveler without a destination. The universe unfolds before you, a canvas painted in light and shadow. You pass through the birthplaces of stars, where clouds of gas swirl in colors unseen by human eyes. Here, the universe is still young, cradling new suns in the arms of glowing nebulae. Further along, a dying star collapses in upon itself, its last breath illuminating the void. You witness its final moments, a brilliant explosion that sends ripples across time. From this death, new elements are born, scattering into space, waiting to become part of planets, oceans, perhaps even life itself. You drift past galaxies colliding in slow motion, their spiral arms entwined like cosmic dancers. Each contains billions of worlds, each world a mystery waiting to be uncovered. But you do not stop. You're heading farther still, to a place where even light struggles to escape. At the edge of everything you see a supermassive black hole. Its presence bends space like a great whirlpool in the ocean of the cosmos. Time slows as you approach. Clocks tick differently here. If you fell inside, moments would stretch infinitely, and the universe outside would age beyond recognition in the blink of an eye. But you do not fall. Instead, you turn away, carried forward by the silent pull of the stars ever onward, toward the unknown. The cosmic microwave background is the oldest light we can see, a remnant of the Big Bang itself. It is everywhere, a faint glow stretched across the sky, whispering the story of the universe's first moments. Venus spins so slowly that, well, a single day on its surface actually lasts 243 Earth days. Meanwhile, it orbits the Sun in just 225 days, meaning a year on Venus is, oddly enough, shorter than a single day. Mars is home to Olympus Mons, a volcano so massive that it towers 3 times higher than Mount Everest. Its base is as wide as France, and if you stood at its summit, the horizon would curve beneath you, making you feel as though you were standing right on the edge of a planet. Our entire galaxy, along with thousands of others, is being pulled toward an unseen force known as the Great Attractor. It is a gravitational mystery, a hidden mass whose presence can be felt but not, fully understood. Across the cosmos, new stars ignite while old ones fade into darkness. Some collapse into white dwarfs, the cooling embers of their former selves, while others end in brilliant supernovae, scattering their essence across the void. Imagine floating in a great cosmic nursery where stars are born from clouds of gas and dust. These nebulae stretch for light years, illuminated by the faint glow of newborn suns. At first there is only cold darkness. Then, slowly, gravity begins to weave its spell. Particles draw closer, spinning, collapsing inward, heating up. What was once a whisper in the void becomes a roar of creation. For millions of years the pressure builds. Deep in the heart of the cloud, a single point begins to glow. A star is forming. And then, in a moment of cosmic breath, it ignites. Nuclear fire bursts forth, pushing back the darkness, shining for the first time in its long life. This star, like all others, will burn for billions of years, warming planets, shaping solar systems, guiding travelers across the night. But one day, far in the future, it too will fade. The cycle of birth and death will continue, written in light across the heavens. At 4.6 billion years old, our Sun is about halfway through its life. In another 5 billion years, it will expand into a red giant, swallowing Mercury and Venus, possibly even Earth, before shrinking into a white dwarf, a glowing ember of its former self. If you could count every grain of sand on every beach and desert, the number would still be smaller than the stars in the observable universe. There are at least 100 billion galaxies, each with hundreds of billions of stars. Far beyond Neptune drifts a planet with no sun. It is called a rogue planet, wandering endlessly through the dark. Without a star to warm it, its surface is frozen, yet deep within, geothermal heat may still burn, keeping hidden oceans alive. Some stars don't simply die, they collapse into neutron stars, spinning rapidly and sending out beams of radiation like cosmic lighthouses. The fastest known pulsar spins 716 times per second, a remnant of an ancient explosion still calling out into the void. Jupiter's Great Red Spot is a storm that has raged for at least 350 years. It is 3 times the size of Earth, with winds that howl at hundreds of miles per hour. If you could stand in its swirling depths, the sky would stretch endlessly above, forever churning in shades of crimson and gold. Close your eyes. Imagine standing on the surface of a world that no human has ever set foot upon. The sky above is not blue, but violet, or perhaps deep crimson, painted by an alien sun. The air is thick with unknown scents, the ground soft beneath your feet. In the distance, twin moons rise, casting silver reflections on a vast ocean. This is not Earth. This is an exoplanet orbiting a distant star waiting to be discovered. Somewhere in the universe, this world may exist. And perhaps in some far-off future, travelers will stand upon its soil, watching their own blue world shine like a distant star in the night. Let's drift even deeper, where time slows, stars whisper, and the cosmos reveals its quiet wonders. The ocean of the universe. Imagine the universe as a great cosmic sea. Galaxies are islands scattered across its vastness, each home to billions of stars. Some are brilliant and young, burning fiercely before fading. Others are ancient and wise, their light stretched thin by time. You are a traveler on this sea, floating between worlds, weightless. You pass a planet where the rain is molten glass, falling sideways in fierce winds. You drift past a moon where volcanoes spew ice instead of lava, building frozen mountains that rise silently in the dark. Farther still, you come to the edge of a great cosmic current, a place where dark matter, unseen but felt, shapes the dance of galaxies. It pulls you onward, whispering secrets of things not yet known. And then ahead, you see something truly strange, a world made entirely of diamonds, glowing in the distant light of its star. The planet of Diamond. There exists a planet called 55 Cancri E, twice the size of Earth, where scientists believe the surface may be covered in graphite and diamond. The immense pressure and heat transform carbon into sparkling crystal, making this world a cosmic jewel. A supersonic shadow. On Mercury, the sun rises and then briefly sets before rising again. This happens because of the planet's strange orbit and rotation, creating an illusion where the sun appears to move backward in the sky. On the exoplanet HD 189733b, winds scream across the surface at 5,400 miles per hour, 7 times the speed of sound. If you stood in its storm, you would be carried around the planet in minutes, lost in a whirlwind of sapphire-colored clouds. Not all planets survive their dance around a star. Some are swallowed, their material torn apart and consumed in fiery destruction. Scientists have found evidence of stars that have devoured entire planetary systems, leaving only hints of their former worlds. The Hercules Corona Borealis Great Wall is the largest known structure in the cosmos. It is a collection of galaxies stretching 10 billion light-years across, a structure so vast that light itself would take billions of years to travel from one end to the other. Close your eyes again. You are no longer floating, you are walking step by step across the fabric of time itself. The past stretches behind you, the future ahead. You pass the birth of the first galaxies, great swirling spirals forming from chaos. You watch the first stars ignite, their light cutting through the endless dark. You walk further still beyond the present into the far future. Galaxies drift apart, their stars slowly fading. The universe grows colder, quieter. One day, far beyond even this moment, the last light will flicker out. And yet, something will remain. Echoes of all that once was, held in the silent fabric of space itself. Perhaps, just perhaps, something new will begin again. The breath of a black hole. You stand at the edge of an abyss, a place where even light cannot escape. A black hole looms before you, its presence bending the very fabric of space. Around it, a glowing ring, an accretion disk, swirls at near the speed of light, radiating with the heat of torn-apart stars. You feel time stretch as you inch closer. A second for you may be 1,000 years for someone watching from afar. If you cross the event horizon, the point of no return, you would never come back. But the universe would watch you freeze, your image forever trapped at the edge, slowly fading like a ghost imprinted on time itself. Inside? No one knows. Some say you would be torn apart, stretched into infinity. Others whisper of wormholes and new universes beyond the veil. But one thing is certain, the laws of physics end here and something else begins. 36. Black holes can sing. As matter falls into a black hole, it releases X-ray bursts in patterns that scientists can study. Some black holes hum at frequencies billions of times lower than human hearing, their gravitational waves rippling through space like an eternal silent song. If you could orbit close to a black hole and return to Earth, you would find that centuries had passed while you experienced only moments. This effect, called gravitational time dilation, shows how gravity bends not just space, but time itself. Ton 618 is a monster, one of the largest black holes ever detected. It is 66 billion times the mass of the Sun and consumes matter so rapidly that it shines brighter than entire galaxies. If placed in our solar system, it would stretch beyond Pluto's orbit. Stephen Hawking discovered that black holes aren't eternal. They slowly lose energy through Hawking radiation. Small black holes may vanish in bursts of energy over trillions of years, fading into nothingness. Some theories suggest our entire universe could have sprung from a black hole in another cosmos. If true, it means every black hole we see might be a gateway to a new universe, each one birthing existence anew. Imagine just for a moment standing at the end of time. The stars have all burned out, leaving behind only cold embers, white dwarfs that are slowly fading to black. Galaxies drift further and further apart, their lights swallowed by an endless night. Out in the distance, a lone red dwarf still burns, casting a faint glow over a frozen world. These stars, the smallest and longest lived, will be the last to die, shining for trillions of years beyond all others. And then, well, silence. Black holes will rule the darkness, swallowing whatever remains, but even they will one day evaporate, leaving nothing but a vast empty void. Yet, the story may not end there. Some theories suggest that in this emptiness, quantum sparks may flicker to life. A new Big Bang could emerge, birthing a new universe just as ours once began. Perhaps this has happened before, perhaps it will happen again. Perhaps the universe is not ending, but only sleeping. So, let's drift beyond the edges of what we know, where reality stretches thin and the unseen whispers its mysteries. Imagine standing before an infinite hall of mirrors. Each reflection is not just you, it's a version of you, slightly different, slightly changed. Some reflections show a world almost identical to ours, others twist into something, well, completely unrecognizable. The multiverse theory suggests that our universe may be just one of many, a single bubble floating in an endless cosmic sea. Some of these universes may follow the same laws of physics as ours. Others may be ruled by forces we simply cannot comprehend, where time flows backward, where stars burn cold, where life exists in forms beyond our wildest imagination. Could there be another you, staring back, wondering the same thing? Tiny fluctuations in quantum fields may have triggered the Big Bang, and, well, some theories suggest this could happen infinitely, creating new universes over and over again. If the multiverse exists, some universes may have different fundamental forces, Gravity could be weaker, atoms might not form, or, life could arise in ways completely alien to us. Some scientists believe subtle patterns in the cosmic microwave background, the oldest light in the universe, might hint at collisions between our universe and others, like fingerprints left behind from another reality. In an infinite multiverse, every possible version of reality could exist. There could be a universe where you never existed, one where you made different choices, or perhaps one where life never arose on Earth at all. In quantum mechanics, a particle does not have a single position until it is observed. Before that, it exists in a superposition, both here and there, everywhere and nowhere, all at once. Two particles can become so deeply connected that changing one instantly changes the other, no matter how far apart they are. If one were on Earth and the other across the galaxy, their connection would remain unbroken, as if space itself did not exist between them. What seems like empty space is actually buzzing with energy. Tiny virtual particles constantly pop in and out of existence, appearing for the briefest moment before vanishing again. Some interpretations of quantum mechanics suggest that nothing truly exists until it is observed. Does the universe need a watcher to bring it into being? The many worlds theory. Every choice creates a new universe. Every time a quantum event occurs, reality may split, creating multiple parallel universes. In one, you are reading this. In another, you never did. Somewhere, another version of you made a different choice, leading to a world that will never touch this one. The time traveler's paradox. Time is a river flowing forward, but what if we could step outside the current? The laws of physics do not forbid time travel, only our understanding does. Black holes, wormholes, and the warping of space-time itself all suggest that time is not as rigid as we think. If you traveled near the speed of light, time would slow for you. A journey that felt like days might be centuries for those left behind. If you entered the gravitational pull of a supermassive black hole, you could experience minutes while the universe outside aged millennia. But what if you went back? What if you changed the past? Would you erase yourself, rewrite history, or create a whole new timeline? Or perhaps, no matter what you do, time has already accounted for your presence, weaving your interference into the fabric of what always was. Time moves slower in strong gravity. Near a massive object like a black hole, time slows down. If you lived near one, you would age more slowly than someone far from its pull. A wormhole is, a theoretical tunnel in space-time, connecting two distant locations, or even two different moments in time. If they exist, they could be shortcuts through both space and, honestly, history itself. As you approach the speed of light, time for you actually slows down compared to the rest of the universe. Astronauts traveling at near light speeds would, return to find Earth far older than when they left. Some particles may travel backward in time. Certain quantum particles behave in ways that, suggest they could actually be moving backward through time. This, raises some fascinating questions. Is the past truly gone, or does it still exist somewhere just out of reach? The future is already written in light. Because you see, light takes time to travel. So when you look at a distant star, you are actually seeing the past. If an alien looked at Earth from, say, 100 light-years away, they wouldn't see us today. They would see the world as it was a century ago. The hidden forces that shape everything. There are 4 known fundamental forces in the universe: gravity, electromagnetism, and the strong and weak nuclear forces. These forces shape galaxies, atoms, and, even our own bodies. But there may be others still unseen. Some believe a 5th force exists, one that explains the mysteries we have yet to solve. Why dark matter holds galaxies together, why the universe expands at an accelerating rate. What if there is a hidden hand, a force we have yet to name, guiding the cosmos in ways we do not yet understand? the phantom matter that holds the universe together. Imagine watching a galaxy spin, stars whirling around its center, vast and majestic. According to our understanding of gravity, the outer stars should be moving slower than those near the core, and yet they don't. They move as if an unseen hand is holding them in place. This is the mystery of dark matter, an invisible substance that does not emit, absorb, or reflect light. We cannot see it, yet it makes up 85% of the matter in the universe. It stretches like an unseen web across the cosmos, binding galaxies together. Some believe dark matter is made of yet undiscovered particles. Others wonder if it is a hidden property of gravity itself. And some whisper, could it be something else entirely? Dark matter is invisible, but everywhere. Though we cannot see it, dark matter surrounds us. Scientists detect its presence by its gravitational pull on galaxies and stars. Without dark matter, galaxies would fly apart. Normal matter alone is not enough to hold galaxies together. Dark matter provides the extra gravity needed to keep them from unraveling. The universe is built on a dark matter web. Galaxies and galaxy clusters are arranged in a vast, invisible web of dark matter. It shapes the structure of the entire cosmos. We may have already detected it without knowing. Underground detectors search for dark matter particles, but so far they remain elusive. Some believe we may have already recorded interactions without realizing what they were. Could dark matter be an entirely different universe? Some theories suggest dark matter could be an entire hidden realm with its own forces, interactions, even life. A dark universe overlapping our own, forever unseen. The universe is expanding faster than it should be. For centuries, we believed gravity would slow the expansion of the universe over time. But in 1998, astronomers discovered something shocking. The universe is not just expanding, it's accelerating. Something is pushing space apart faster and faster. Scientists call this force dark energy, but no one truly knows what it is. Is it an unknown field permeating space, a property of empty space itself? Or could it be a sign of something even stranger, a new physics waiting to be discovered? The universe is growing bigger every second. Every moment galaxies drift farther apart. Space itself stretches, carrying them away on an invisible tide. Dark energy is stronger than gravity. Gravity tries to pull everything together, but dark energy pushes it apart. It is the dominant force shaping the future of the cosmos. We only discovered dark energy recently. Before 1998, we thought the universe's expansion would slow down. The discovery of dark energy rewrote our understanding of the cosmos. The fate of the universe depends on dark energy. If dark energy grows stronger, the universe could expand forever, stretching into cold emptiness. If it weakens, gravity may one day pull everything back in a big crunch. Some think dark energy is an illusion. A few scientists propose that our universe isn't expanding faster. Maybe space itself is changing in ways we don't yet understand. Are we living in a cosmic simulation? Look around. Everything you see, stars, galaxies, even your own thoughts, could be nothing more than lines of code running inside an unfathomable machine. This is the simulation hypothesis, the idea that our universe might not be real. If an advanced civilization were powerful enough, they could create artificial realities, rich and complex. And if they could, how do we know we aren't already inside one? Some scientists think we could prove it. Some researchers are searching for glitches in reality, tiny inconsistencies in physics that might reveal a simulated nature. If we are in a simulation, it could be one of many. If our universe is a simulation, what if it is just one among billions, nested within each other like Russian dolls? Cosmic rays might hold the answer. Some scientists propose that the way cosmic rays move could reveal whether space itself is pixelated, like a digital simulation. Would it matter if we were simulated? If everything feels real, does it make any difference if it is? If you are part of a simulation, your thoughts, dreams and experiences are still real to you. What if we are the ones who will create the simulation? Perhaps we are not trapped in one. Perhaps we are heading toward a future where we create one, becoming the architects of entire artificial universes. The universe hides more than it reveals. Every mystery we solve leads to deeper, stranger questions. Dark matter is unseen, dark energy is unknown, and time itself may not be what we think. Could we be living inside a grand cosmic illusion, or is the true nature of reality something we have yet to even imagine? What shall we uncover next? The fate of the last stars, the final moments before the universe ends, or the possibility that something exists beyond it? The last light in the universe, the night sky we see today is filled with stars, brilliant and burning, but this will not always be so. One by one the stars will die. First, the massive ones will go, erupting in spectacular supernovae, leaving behind black holes and neutron stars. Then the smaller ones will fade, white dwarfs cooling into blackened cinders. The last stars, the tiny red dwarfs, will burn on for trillions of years, but even they will one day flicker and die. And then darkness. No new stars will be born, no light will remain. Only the cold, ancient remnants of a universe that once burned with life and energy. The last stars will burn for trillions of years. Red dwarfs, the smallest and longest living stars, will shine for up to 10 trillion years before they too fade into the void. White dwarfs will become black dwarfs. The last remnants of stars, called white dwarfs, will slowly cool over quadrillions of years, becoming black dwarfs, frozen spheres of carbon floating in endless night. Black holes will be the last beacons of energy. Even after all the stars are gone, black holes will remain, devouring what little matter still exists and radiating faint energy. The universe will be nothing but dead stars and black holes. After 10 to the power of 40 years, nearly all matter will have been consumed or drifted into nothingness. A universe of cold, dark husks will stretch on endlessly. The end of star formation is called the degenerate era. This future, where no new stars are born, is known as the degenerate era, a time when the universe has run out of fuel and is left with only the remnants of its former brilliance. The slow death of black holes. For eons, black holes will dominate the cosmos, but even they will not last forever. Through a process called Hawking radiation, black holes slowly evaporate, losing energy particle by particle. For the largest black holes, this process takes an unimaginable amount of time, 10 to the power of 100 years or more. Yet one by one they will fade, growing smaller, dimmer, until at last they disappear in a final, quiet flash of energy. With them, the last structures of the universe will vanish. Black holes shrink over time. Hawking radiation slowly steals energy from black holes, causing them to lose mass and eventually evaporate. The smallest black holes will die first. Tiny black holes will evaporate in mere billions of years, but, supermassive black holes will take something like 10 to the power of 100 years or even longer to disappear. The last black hole will die in the darkest age. When the final black hole vanishes, nothing will remain, only empty space stretching endlessly. The death of a black hole is invisible. As a black hole shrinks, its radiation weakens. Its final moment may go unnoticed, as there will be nothing left to observe it. The universe will be a vast, silent void. Once the black holes are gone, no heat, no energy, no movement will remain, only a featureless emptiness beyond imagination. The ultimate fate, the heat death of the universe. So what happens when nothing is left? If dark energy continues to expand space, matter will be stretched apart. Galaxies will drift so far that, their light will never reach one another. Eventually all motion will cease. This is the heat death, the moment when the universe reaches maximum entropy, meaning all energy has been evenly spread out. No stars, no planets, no black holes, just a vast, cold and eternal void. Time as we know it will lose meaning. With nothing left to change, the universe will be frozen in stillness. It is perhaps the quietest, loneliest future imaginable. Heat death means maximum entropy. Entropy, you see, is the measure of disorder. When the universe reaches maximum entropy, no more useful energy remains. There will be no more heat or motion, With no energy left to power movement, even atoms will stop vibrating. The universe will be at absolute zero. This could take, well, 10 to the power of 100 years or more. Heat death is so far in the future that even black holes will have disappeared long before it happens. Time may lose all meaning. With nothing left to measure change, time itself might become meaningless, an eternal, unchanging void. The universe might never truly end. Though everything will be still and lifeless, the universe will continue to exist, frozen in place forever. Is this the end, or just the beginning? This seems like the final chapter, a cold, dark universe where nothing moves, nothing shines, and nothing changes. But could there be something beyond this? Some theories suggest that after reaching maximum entropy, the universe might find a way to restart, perhaps through quantum fluctuations, a new Big Bang, or a cycle of cosmic rebirth. Others believe our universe may simply fade into nothingness, dissolving into a deeper reality we have yet to comprehend. If the universe is a story, is this truly the final page? Or is it simply waiting for the next chapter to be written? Could the universe be reborn? The last black hole has vanished, the stars are long gone, and the universe has reached its cold, motionless end. But endings are often just new beginnings. Could something rise from this cosmic graveyard? Could the universe be reborn like a phoenix from the ashes? Some scientists believe the universe might be part of an endless cycle, collapsing, exploding, expanding, and then collapsing again. Others suggest that even in the most absolute void, quantum forces could spark new creation. Let's step beyond the darkness and into the unknown, where the universe may yet dream of another beginning. The Big Bounce, a universe that never truly dies. What if the Big Bang wasn't the first? Some physicists suggest that instead of expanding forever or fading into nothing, the universe might one day stop, shrink, and collapse in on itself. This is called the Big Crunch, a moment when everything that exists gets squeezed into a dense, hot point, much like how our universe began. But rather than staying collapsed, some theories say this compressed state could explode outward in a new Big Bang, a Big Bounce, creating an entirely new universe. If this is true, then our cosmos isn't the first nor the last. It's just one heartbeat in an infinite cycle of expansion and rebirth, where each universe leaves behind traces of the ones that came before. Could echoes of past universes still exist, hidden in the cosmic background radiation? Perhaps like faint memories of dreams long forgotten, the past universes still whisper to us. The universe might reset itself through quantum fluctuations. Even in complete emptiness, the laws of physics allow for tiny, random bursts of energy called quantum fluctuations. Imagine a still pond with no ripples, perfectly calm. Now imagine that every so often, tiny bubbles form on its surface for no reason. These bubbles are like quantum fluctuations, appearing and disappearing, seemingly from nothing. Now take that idea and apply it to the vast emptiness of space itself. If the universe reaches a state where nothing exists, no stars, no galaxies, not even black holes, could a quantum fluctuation cause a new Big Bang? If so, then creation itself is inevitable. No matter how empty space becomes, there is always a chance, however small, that something new will arise. Maybe our universe was born from just such a fluctuation, and maybe one day another will take its place. We think of black holes as endings, places where matter disappears forever. But what if they are actually beginnings? Some physicists believe that the immense gravity inside a black hole could tear a hole in space-time, leading somewhere new. Imagine falling into a black hole. Instead of being crushed into nothingness, what if you emerged on the other side, inside a completely different universe? This idea suggests that black holes might act as cosmic seeds, birthing new universes each time they form. Our own universe could have been created from the collapse of a black hole in a larger, older universe. If true, then our cosmos is part of a vast tree of universes, each one sprouting from the black holes of another. Perhaps beyond the event horizon of every black hole, an entirely new reality is unfolding, unseen by us. If one universe fades away, must it truly be the end? Some scientists propose that when our universe reaches its final frozen state, it may not remain that way forever. Instead, it could serve as the foundation for something new. One possibility is that vacuum decay, a sudden shift in the very nature of space itself, could cause an entirely new universe to bubble into existence. Another is that a hidden dimension could unfold, birthing a fresh cosmos from the remains of our own. Much like a dying tree releasing seeds into the wind, our universe might give rise to another, even as it fades. What if time itself never had a starting point? We think of time as moving forward, from the past to the present and into the future. But what if time has no edges, no beginning, no end? If so, then the universe may always have existed in some form. It may change, evolve, collapse and restart, but it never truly disappears. This idea suggests that existence is simply an unbroken thread stretching infinitely in both directions, an eternal unfolding of reality that never had a true start and will never find a final end. And if that's true, then nothing is ever truly lost. We look at the universe and see everything, every star, every galaxy, every planet. But what if our universe is just one of many? The idea of a multiverse suggests that our cosmos is not alone. Instead, it may be one bubble in an infinite ocean of other universes, each one with its own rules, history, and possibilities. If true, then somewhere out there, another universe might exist where gravity is stronger, where atoms are different, where time flows in reverse. Or perhaps in some distant parallel world, there is another version of you looking up at the sky and wondering the same thing. Some physicists believe the Big Bang wasn't a one-time event, but just one of countless cosmic explosions, each creating its own universe. If true, then space isn't just big, it's endlessly, unimaginably vast, with universes sprouting like stars in a cosmic forest. Black holes are strange things. When something falls into one, we assume it's lost forever. But what if, instead of being destroyed, that matter is reshaped into a new reality? Some theories suggest that every black hole contains a new universe inside it. That means our own universe might have been born from the collapse of a star in another older cosmos. If true, then the cycle of universes is never ending. Each one gives birth to new ones, like an infinite web of existence. In another universe, the laws of physics might be entirely different. Gravity could be stronger, atoms could be unstable, stars might never form. Some universes might be chaotic and short-lived, while others might last forever. Some may have completely different elements, meaning life, if it exists, would be unlike anything we can imagine. We can only guess what strange and wonderful worlds might exist beyond our own. Our universe has just the right conditions for life. Stars shine, planets form, and chemistry allows for living things to exist. Why? One answer is the anthropic principle. If there are infinite universes, then at least one was bound to have the right conditions for life. And that's the one we live in. We see a universe that makes sense to us because we are here to see it, but in countless other universes, the conditions may be completely different. If universes are always being created, then the idea of nothingness might not exist at all. There may never be a true void, only an endless, eternal unfolding of reality. And perhaps even when one universe ends, another is already beginning. The cosmos is vast beyond imagination. And as you close your eyes and drift into sleep, remember, even in the deepest silence, even in the longest night, the universe may never truly stop dreaming. The stars shine, the planets spin, and galaxies drift across the vastness of space. But what holds it all together? The universe is not just what we see, It is shaped by invisible forces, hidden energies that weave through the cosmos like unseen threads. Without them, the universe as we know it could not exist. Some of these forces are familiar. Gravity pulls us to the Earth, electromagnetism powers our technology, but others remain a mystery, lurking in the darkness of space, bending reality in ways we still don't fully understand. What if some of the greatest forces in the universe are the ones we cannot see? Look up at the night sky. Every star, every galaxy, every glowing nebula, these make up only 5% of the universe. The rest, it's invisible. Scientists have discovered that galaxies spin far too fast. If only the matter we can see was holding them together, they should have torn apart long ago. But something unseen is binding them, something with mass, something powerful. We call it dark matter. Though we cannot see or touch it, dark matter makes up nearly 27% of the universe. It forms an invisible web that galaxies are strung upon, guiding their movements like an unseen hand. What is it? Nobody knows for sure. It does not emit light, does not interact with normal matter, and passes through us as if we weren't even there. But without it, the universe would be unrecognizable. Could dark matter be made of unknown particles? Or could it be something stranger? Echoes of another universe overlapping with ours. We do not yet have the answers, but we know that something unseen is watching over the stars. If dark matter holds galaxies together, dark energy pushes them apart. Back in 1998, astronomers made a truly shocking discovery. The universe isn't just expanding, it's accelerating. Something is, forcing galaxies away from each other at an ever-increasing speed, stretching space itself like a growing balloon. We call this force dark energy, and astonishingly, it makes up nearly 68% of the universe. Imagine, just for a moment, a battle between two great cosmic forces. Dark matter pulls galaxies inward, trying to bind them together. Dark energy pushes them apart, stretching space wider and wider. For now, dark energy is winning. One day, if it grows too strong, it could rip everything apart, even atoms themselves, in a final event called the Big Rip. But where does dark energy come from? Is it a fundamental property of space? Or is it perhaps something more mysterious? A hidden force we have yet to comprehend? The truth is, we simply don't know, but it is there, guiding the fate of the cosmos. We think of space as empty and time as steady. But Einstein showed us that both space and time are woven together like fabric, and just like fabric, they can bend, stretch and twist. Massive objects like planets, stars and black holes create dents in this fabric, bending the flow of time itself. That's why, time runs slower near a black hole than it does on Earth. In extreme cases, space-time can twist into impossible shapes. Wormholes, cosmic strings, even time loops where past and future fold into each other. If we could master this hidden structure, could we travel across the universe in an instant? Could we bend time itself? For now, space-time remains a silent sculptor, shaping the universe in ways we're only beginning to understand. Everything in the universe has mass. But why? The answer lies in an invisible energy field that fills the cosmos, the Higgs field. Discovered in 2012, the Higgs field is a force that interacts with particles, giving them weight. Without it, atoms would not form, stars would not shine, and life itself could not exist. Some have called the Higgs boson the God particle because it is so fundamental to reality. But what if the Higgs field could change? Some theories suggest that if it shifted, everything in the universe, matter, energy, even the very laws of physics, could collapse in an instant. For now, the Higgs field is stable, but the universe is always changing, always shifting. Could it one day flicker, resetting reality itself? Gravity is the force we know best. It keeps our feet on the ground, it holds the planets in orbit, it shapes the stars. But compared to the other forces of nature, gravity is strangely weak. A tiny magnet can lift a paperclip against the entire gravitational pull of the Earth. Why? Some theories suggest that gravity might not be weak at all. It might be leaking into other dimensions we cannot see. If true, this could explain why it seems so feeble in our universe, yet powerful enough to shape galaxies on cosmic scales. Gravity is also unique because it warps time. The closer you are to a massive object, the slower time moves for you. If you lived on a planet near a black hole, you might age only a few years while centuries pass elsewhere. Could gravity be the key to understanding hidden dimensions? Or is it the last piece of a puzzle we have yet to complete? The universe is stranger than we ever imagined. We live in a universe shaped by unseen forces, dark matter, dark energy, the bending of space-time, the strange field that gives us mass. We cannot see them, but they guide our reality in ways we're only beginning to comprehend. Perhaps one day we will learn to harness these forces, bending space, controlling gravity, even unlocking the secrets of the multiverse. But for now, as you drift into sleep, remember, the cosmos is not just what we see. It is a tapestry of mysteries stretching beyond our imagination, waiting to be unraveled. Black holes, where time and space collapse. Deep in the heart of the cosmos, there are places where the laws of physics break down. Black holes, born from the deaths of massive stars, are cosmic traps from which nothing, not even light, can escape. A black hole is not just an object, it is a tear in the fabric of space-time. At its center lies a singularity, a point so dense that space and time themselves crumble. Anything that falls in is lost, swallowed by an abyss where time slows to a stop. But black holes do not just destroy, they shape the universe. They sculpt galaxies, bending the paths of stars. Some spin so fast that they twist space around them, dragging reality itself into a cosmic whirlpool. And at the edge of a black hole, something strange happens. Quantum particles flicker into existence, creating a glow of energy known as Hawking radiation. Over time, this radiation steals energy from the black hole, causing it to shrink and eventually disappear. What happens when a black hole dies? Does it explode, releasing everything it swallowed? Or does it leave behind a gateway to another universe? For now, black holes remain one of the greatest mysteries of the cosmos, silent, invisible, and waiting in the darkness. White holes, the opposite of a black hole. If black holes consume everything, is there something in the universe that does the opposite? Some theories predict the existence of white holes, objects that cannot be entered, only exited. If a black hole pulls things in and never lets them escape, a white hole would push things away and never let them enter. Imagine an explosion frozen in time, constantly ejecting light, matter, and energy. That is a white hole, a place where time may flow backward instead of forward. No white holes have ever been seen, but some physicists believe that the Big Bang itself might have been a white hole explosion, a cosmic outpouring of energy that gave birth to everything we know. Could white holes be connected to black holes? Could something that falls into a black hole emerge from a white hole in another part of the universe? If they exist, white holes could hold the key to understanding the deep connection between time, space, and the fate of the cosmos. If space and time are like fabric, could they be folded? Could we create a tunnel between distant places in the universe, a bridge that allows us to step across vast cosmic distances in an instant? This is the idea behind wormholes, hypothetical tunnels that connect 2 points in space-time. Enter one side and you might emerge on the other side of the galaxy or even in another universe. Einstein's equations suggest that wormholes are possible but unstable. If one formed, it might collapse instantly, snapping shut before anything could pass through, unless something holds it open. Some theories suggest that a special kind of exotic matter with negative energy could stabilize a wormhole, making interstellar travel possible. If wormholes exist, they could change everything. No more years-long journeys to other planets, just a single step through a cosmic doorway. But if we ever find one, the biggest question will be, where does it lead? The universe is vast, but does it have an edge? If you traveled in one direction forever, Would you eventually hit a wall? Or would you loop back to where you started, like an explorer sailing around the Earth? We don't know for sure. Some theories suggest the universe is infinite, stretching forever in all directions. Others propose that it is finite but unbounded, curving back on itself in higher dimensions. If the universe has an edge, what lies beyond it? A void? Another universe? Or something we cannot yet imagine? The farther we look, the more questions we find. And yet every new discovery brings us closer to understanding the true shape of existence. The multiverse. Are there infinite universes? What if our universe is not alone? Some scientists believe that our cosmos is just one of many, a tiny bubble in an endless ocean of universes. This idea is called the multiverse, and it suggests that every possibility that could ever happen has already happened somewhere. In another universe, you might be living a completely different life. In another, the laws of physics could be entirely different. No gravity, no atoms, no stars. There are many ways a multiverse could exist. It could come from quantum physics, where every decision creates a branching reality. It could come from inflation, where new universes are constantly forming in an infinite cosmic sea. But if other universes exist, could we ever reach them? Could a black hole be a doorway? Could a wormhole lead to a parallel world? Or are we forever trapped in our own bubble of reality, separated from countless others by forces we cannot yet comprehend? The universe is bigger, stranger, and more mysterious than we ever imagined. We are surrounded by unseen forces, dark matter, dark energy, gravity bending time itself. We live in a reality shaped by cosmic monsters, black holes, white holes, and the possibility of wormholes that could take us anywhere. And beyond all that, there may be other universes waiting just out of reach. Perhaps one day we will step through the doorway to another world. But for now, as you close your eyes and drift into sleep, remember, the cosmos is full of wonders, and we are only just beginning to understand them. The fate of the universe. How will it all end? Every story has an ending, even the universe itself. But how will it happen? The cosmos was born in the Big Bang, an explosion of energy that sent space and time expanding outward. But one day this expansion must meet its fate. Scientists have proposed several possibilities, each more mysterious than the last. Will the universe collapse into itself, ending in a crushing fireball? Will it freeze into eternal darkness, drifting into the void? Or will reality itself be torn apart, dissolving into nothingness? Let's explore the possible endings of everything. If gravity is strong enough, the expansion of the universe could slow, stop, and then reverse. Galaxies would begin to fall back toward each other, drawn inward by their own mass. Stars would collide, worlds would be obliterated, and the entire cosmos would shrink into a single burning point, a cosmic undoing of the Big Bang. Some believe that this could lead to a new Big Bang, a rebirth of the universe from its own ashes. If this is true, the cosmos may be trapped in an endless cycle, expanding, collapsing, and being reborn again and again. Could we be just one of many universes that have existed before? If dark energy continues to push galaxies apart, the universe will never stop expanding. Over time, galaxies will drift so far away from each other that their light will never reach us. Stars will burn out one by one, leaving behind only cold, lifeless remnants. Even black holes will slowly evaporate, vanishing into the darkness. In the end, the universe would become a vast, frozen void, a place where nothing can happen, where time itself has no meaning, no fire, no light, no life, just an endless sea of cold and silence. What if dark energy doesn't just push galaxies apart, but keeps growing stronger? Over time, dark energy could become so powerful that it tears apart everything: galaxies, stars, planets, even atoms themselves. Imagine looking up at the night sky and watching the stars vanish one by one. Then the planets break apart. Then the very molecules that make up your body stretch and disintegrate. Finally, even space-time itself would rip apart, dissolving reality into nothingness. This would be the most violent end possible, an ultimate unraveling of existence itself. There's another, even stranger possibility. The universe is ruled by quantum fields, mysterious energy fields that shape everything. But what if one of these fields is unstable? If a quantum field suddenly shifted to a lower energy state, a bubble of this new reality could appear anywhere, at any time. And this bubble would expand at the speed of light, consuming everything in its path. We would never see it coming. One moment, the universe would exist. The next, it would be replaced by something else, something governed by different laws of physics. Would it be a new universe, a blank void? We cannot know. But if vacuum decay happens, it will be the quickest and most silent way for everything to end. Even if our universe ends, that might not be the end of everything. Some theories suggest that black holes might create new universes inside them, tiny pockets of reality hidden beyond the event horizon. If this is true, our own universe might have been born from the collapse of a previous one. Others propose that the end of our universe could trigger a new Big Bang, birthing a fresh cosmos from the remnants of the old. If this is the case, the universe may never truly die. It may simply transform over and over in an infinite cosmic cycle. Perhaps we are living in just one of many universes, waiting for the next great awakening. The cosmos has a beginning and an end, but what lies beyond? Could we be part of a never-ending cycle? Could we find a way to escape the fate of the universe? Or are we simply passengers in a grand cosmic story, waiting to see how it all unfolds? As you close your eyes and drift into sleep, remember, the stars will burn, the galaxies will dance, and the universe will one day meet its fate. But even in the quiet darkness of the cosmos, there's always the possibility of a new dawn. Black holes are the darkest, most mysterious objects in the universe, places where gravity is so strong that even light cannot escape. They are born from the deaths of massive stars, collapsing into themselves and creating a cosmic abyss. But what truly lies inside a black hole? A portal to another universe, the end of time, or something even stranger? Let's step closer to the event horizon, the point of no return, and peer into the unknown. Imagine floating in space, gazing at a black hole. It appears as a dark, empty void, surrounded by a glowing ring of light, stars and gas being torn apart as they spiral inward. This glowing border is called the event horizon, the boundary beyond which nothing can escape. If you crossed it, not even a message could be sent back. To an outside observer, you would appear frozen at the event horizon, stretched and distorted, but from your own perspective, you would fall inward, deeper and deeper toward the unknown. What happens next is one of the universe's greatest mysteries. As you fall toward a black hole, the difference in gravity between your feet and your head would become, well, extreme. The closer part of your body would be pulled much harder than the farther part. This would stretch you into a thin, noodle-like shape, a process known as spaghettification. Eventually, you would be torn apart at the atomic level, becoming part of the black hole's mass. But if the black hole is large enough, you might cross the event horizon without feeling a thing, falling deeper into darkness, never to return. At the heart of a black hole lies the singularity, a point of infinite density where the laws of physics break down. No one knows what happens inside a singularity. It could be a place where space and time cease to exist. It could be a gateway to another universe. Or it might be something completely beyond human understanding. Some scientists believe that the singularity doesn't really exist, that something unknown, perhaps a new law of physics, prevents it from forming. Could black holes hold the answers to the deepest mysteries of the cosmos? Some theories suggest that when matter falls into a black hole, it does not disappear. It simply moves to another place. Could black holes be portals to other universes? If you fell into one, would you emerge on the other side in a different reality? Some believe that every black hole creates a new universe inside it. If this is true, then our own universe might have begun inside a black hole, born from the collapse of a previous cosmos. Are black holes the seeds of new universes, endlessly branching out into infinity? For a long time, scientists believed that black holes were eternal. But physicist Stephen Hawking discovered something astonishing. Black holes slowly evaporate over time. Through a process called Hawking radiation, black holes lose tiny amounts of energy and shrink. Eventually, they will disappear in a final burst of energy, leaving nothing behind. This means that black holes are not truly forever. They too will one day fade into the void. But before they vanish, what happens to everything they swallowed? Could information be lost forever? Or could it be released back into the universe in some unknown form? The mystery remains. Black holes are cosmic paradoxes, places where time stops, space twists, and the known laws of physics, well, they just crumble. Perhaps they are cosmic tombs, swallowing all that enters, or perhaps they are gateways, opening paths to places beyond our imagination. As you close your eyes and drift into sleep, remember this. Somewhere in the universe, a black hole is waiting, a doorway to the unknown, calling to those brave enough to fall. Beneath the grand expanse of galaxies, beneath atoms, beneath even the tiniest particles, there is a world unlike anything we know. A world where objects exist in multiple places at once, where particles teleport, and where reality itself seems, well, uncertain. This is the quantum realm, the foundation of everything, yet so bizarre that even the greatest scientists struggle to understand it. What if the true nature of the universe is hidden in the smallest things? Imagine you are standing in a room. You're either in one spot or another. There's no in-between. But in the quantum world, particles can be in multiple places at the same time. This is called superposition. An electron, for example, doesn't have just one location. It exists in all possible locations at once until we measure it. The moment we look, the electron chooses a single position. Does this mean reality only becomes real when observed? And if so, what happens when no one is watching? If you take two particles and entangle them, something strange happens. No matter how far apart they are, even across the universe, they remain connected. If you change one, the other reacts instantly, faster than the speed of light. It's as if information is traveling through an unseen dimension. Einstein called this spooky action at a distance, and to this day no one truly understands how it works. Could this be proof that everything in the universe is secretly linked, connected by invisible threads across time and space? One of the strangest discoveries in quantum physics is that observation changes reality. In an experiment called the double-slit experiment, scientists found that light can behave like both a particle and a wave. But when someone watches the experiment, light chooses to behave as just one. Does this mean consciousness plays a role in shaping reality? Is the universe truly real, or is it just a vast quantum dream, unfolding only when observed? If so, who is the ultimate observer of the cosmos? In the quantum world, time doesn't always move forward. Some experiments suggest that future events can influence the past, as if time were not a straight line, but a vast web of possibilities. Could this mean that the universe constantly rewrites itself, adjusting the past based on what happens in the future? If time is flexible at the smallest scale, could it also be flexible on the grandest scale? Could we someday unlock the secret to time travel, not in science fiction but in reality? If the universe follows strange, unpredictable quantum rules, could it be a simulation? Some scientists believe that reality itself might be a kind of program running on a cosmic computer beyond our comprehension. If so, The quantum world, where things exist in all states until observed, might be the code running in the background. What if the stars, the galaxies, even our own minds are just part of a simulation too vast to detect? And if this is true, then the biggest question remains, who or what is running the simulation? Look up at the night sky. Every star you see is a sun, many with planets orbiting around them, billions of stars, trillions of planets, infinite possibilities. Yet in all this vastness, we have found no sign of alien life. Are we truly alone, or is life out there waiting for us to discover it? Let's journey beyond Earth, searching for life among the stars. The Fermi paradox. Where is everyone? In 1950, physicist Enrico Fermi asked a simple but haunting question. If the universe is so big, where is everyone? With billions of planets capable of supporting life, we should see evidence of aliens, radio signals, spacecraft, or even ruins of ancient civilizations, but we see nothing. There are many possible explanations. Maybe intelligent life is rare. Earth could be one of the few places where life evolved beyond microbes. Maybe civilizations destroy themselves. War, pollution, or artificial intelligence could wipe them out before they explore space. Maybe they are hiding. Advanced beings might watch us from the shadows, choosing not to reveal themselves. Or perhaps the answer is stranger than we can imagine. Life on exoplanets, a second Earth. Beyond our solar system, astronomers have discovered thousands of exoplanets, worlds orbiting distant stars. Some are similar to Earth with the right conditions for liquid water. Could life already exist on one of these distant worlds? Scientists are listening for alien radio signals, searching for signs of oxygen in distant atmospheres, and even planning future missions to explore alien planets. One day, we may wake up to the news. Life has been found beyond Earth. Would it be microbes, plants, or something far more advanced? Could life exist in our own solar system? We think of our solar system as lifeless, but there are places where life could exist. Europa, a moon of Jupiter, has an ocean beneath its icy surface. Could alien creatures swim beneath its frozen shell? Enceladus, a moon of Saturn, erupts with water from underground seas. Could microscopic life forms be hiding beneath the ice? Mars, once covered in rivers and lakes, may still have underground life, surviving in hidden caves or deep below the surface. If we find life in our own solar system, it would mean one incredible thing. Life is common in the universe. The Great Filter. Why haven't we met aliens? Some scientists believe there is a great barrier, a filter, that stops civilizations from reaching the stars. This great filter could be life itself is rare. Maybe most planets never develop even the simplest forms of life. Complex life is uncommon. Microbes may be everywhere, but intelligent life may be incredibly rare. Advanced civilizations destroy themselves. Maybe every intelligent species eventually creates weapons too dangerous or technology that wipes them out. The scariest possibility, maybe the great filter is ahead of us, a future challenge that we too might not survive. Or perhaps the answer is even darker. The dark forest theory. Are aliens hiding from us? Imagine the universe as a vast dark forest. Every civilization is like a hunter silently walking through the trees. Some hunters stay quiet, others reveal themselves. But in a dark forest, revealing yourself could be dangerous. The dark forest theory suggests that advanced alien civilizations may be hiding because any contact could be deadly. If a powerful civilization sees another, it might choose to eliminate them before they become a threat. Is this why we hear only silence? Are there alien watchers listening but never speaking, waiting in the shadows? And if we ever find them, will they welcome us or see us as a threat? Parallel universes. Do other realities exist? What if this universe is not the only one? Scientists believe there could be countless other universes, each with different laws of physics, different histories, and even different versions of you. If true, the multiverse would be the greatest mystery of all, a cosmos beyond our cosmos. In the quantum world, particles can exist in multiple states at once, but when we observe them, they choose one state. But what if they don't really choose? The many worlds interpretation suggests that instead of collapsing into one outcome, the universe splits into multiple realities. Every time you make a choice, whether to turn left or right, to speak or stay silent, a new universe is born where you chose differently. In one world, you are reading this, in another, you never found it. In yet another, you are living a completely different life. Are we constantly branching into new realities without even knowing it? Imagine the universe as a vast ocean with bubbles floating in it. Each bubble is its own universe, separate and unreachable. If this is true, then our universe is just one of many. Some might have completely different laws of physics, where time moves backward, where light is slower, where life is impossible or unimaginably strange. Could there be a way to cross between these cosmic bubbles? If so, what would we find on the other side? Have you ever remembered something one way, only to find out it never happened that way? Many people share memories of things that don't match recorded history, like the spelling of a famous brand or details in a childhood book. Some believe this is proof of memories leaking between parallel universes, that we sometimes slip into slightly different realities without realizing it. Is our world subtly shifting? Are we experiencing echoes of alternate timelines? If parallel universes exist, could we visit them? Some theories suggest that black holes, wormholes, or certain quantum events might act as gateways, but the energy needed to cross between realities could be beyond anything we can imagine. Yet, if civilizations more advanced than ours exist, could they have already found a way? Could UFOs, strange disappearances, or mysterious phenomena be signs that someone or something is slipping between worlds? Are we just one simulation among many? If there are infinite universes, could one of them be a simulation? Could our own reality be a carefully crafted world designed by beings from another universe? If so, are we inside a simulation, inside another simulation, layered infinitely? And if one day we discover the truth, what happens next? The edge of the universe. Is there an end to everything? When you look up at the night sky, you are gazing into the past. Light from distant galaxies has traveled billions of years to reach your eyes. But beyond those galaxies, far beyond the reach of any telescope, does the universe ever end? Or does it go on forever, stretching into the infinite unknown? The observable universe, a limit we cannot cross. The observable universe is everything we can see, roughly 93 billion light-years across. But this is not the whole universe. Light takes time to travel, and some parts of the cosmos are so far away that their light has not reached us yet. Beyond our visible horizon, the universe could continue endlessly, or it could curve back on itself, like the surface of a giant sphere. What lies beyond what we can see? The cosmic horizon, a boundary we can never reach. If you could travel at the speed of light, you would still never reach the edge of the universe, because space itself is expanding faster than light. This means there are galaxies that will forever remain out of reach. No matter how advanced we become, some parts of the cosmos are lost to us, hidden beyond an unreachable horizon. What secrets are locked away beyond the limits of our sight? The expanding universe, growing into the unknown. The universe is not static, it is growing, stretching, expanding. Every second, distant galaxies move farther apart. Not only that, but the expansion is accelerating. Something unseen, dark energy, is driving space to expand faster and faster. If this continues, in the far future, galaxies will vanish beyond our view, swallowed by the vastness of space. The universe will become a lonely, empty place with nothing left but darkness. What if the universe has no edge, not because it is infinite, but because it wraps around itself? If space is curved, then traveling in one direction forever might bring you right back to where you started, like walking in a giant cosmic loop. If this is true, then there is no true edge to the universe, only an endless cycle repeating across time and space. If there is an edge to our universe, what lies beyond it? Some theories suggest that our universe is just one bubble in a sea of countless others. Each may have its own laws of physics, its own stars and galaxies, perhaps even its own version of you. Could there be a way to escape our universe and explore the infinite beyond? Or are we forever trapped in this cosmic bubble, unable to see the greater reality beyond the stars? You're right. Let's continue with fresh details and everything that begins must also end. The universe, born in the brilliance of the Big Bang, is on a journey toward its final destiny. Scientists have proposed multiple scenarios for how the cosmos might meet its ultimate fate. Some endings are slow and cold, others are violent and catastrophic. But all of them remind us of one thing: nothing lasts forever. The most accepted theory of the universe's fate is the Big Freeze, also called the heat death. As the universe expands, it becomes colder and emptier. Stars run out of fuel and fade away, one by one, until no more light shines in the cosmos. Even black holes, the most powerful objects in existence, will slowly evaporate due to a strange process called Hawking radiation. In the end, all that remains is a vast featureless void, an eternity of frozen stillness. No stars, no galaxies, no life, just darkness stretching forever. But what if, instead of expanding forever, the universe reverses course? In the Big Crunch scenario, the force of gravity eventually overcomes the expansion. Galaxies begin to drift closer instead of farther apart. Stars collide, planets crumble, everything collapses inward, pulled toward an inescapable point. The universe shrinks back to a singularity, the same state it started from. Could this be the end, or the beginning of another Big Bang? If the universe collapses into itself, could it explode again? The Big Bounce theory suggests that the universe is trapped in an eternal cycle, expanding, collapsing and rebirthing over and over again. If this is true, then the current universe is just one version in an endless loop. Everything we know, every galaxy, every planet, every moment, has already happened before, countless times, and will happen again. Perhaps we're living in a universe that has existed before and will exist again. What if expansion never stops, but speeds up so much that the very fabric of space is torn apart? In the Big Rip scenario, dark energy, the mysterious force driving the expansion, becomes stronger over time. At first, galaxies separate, then solar systems dissolve. Then atoms themselves are ripped apart, leaving only a storm of energy. If this is our fate, the universe will not fade away slowly, nor will it collapse. Instead, it will be violently torn apart. The most terrifying possibility: the universe might end without warning. Our universe may exist in a false vacuum, a temporary, unstable state. If it ever decays into a lower energy state, an unstoppable bubble of destruction would expand at the speed of light. Nothing could escape. Planets, stars, galaxies, all would vanish in an instant, rewritten by the laws of a new universe. It may not happen for trillions of years. Or, well, it could happen right now. The fate of the universe is a mystery we are only beginning to understand, but one thing is certain. No matter which ending comes, it will be billions, trillions, or even quadrillions of years from now. For now, the universe is still alive, still expanding, still filled with the beauty of stars and galaxies. And for now, we are here to witness it. Time is a river, flowing endlessly from past to future. But why can we remember yesterday yet never see tomorrow? Why do stars burn out but never reignite? And why do we grow older but never younger? The answer lies in something called entropy, the measure of disorder in the universe. Over time, entropy increases, meaning things become more chaotic and less organized. A broken glass never unbreaks. A drop of ink spreads through water but never gathers back into a perfect sphere. This one rule shapes everything. The past is orderly, the future is messy, and so time moves forward, never back. What if one day the arrow of time flipped? What if stars reignited, rivers flowed backward, and people unaged into childhood? Some theories suggest that if the universe contracts in a big crunch, time itself could reverse, playing out in a mirrored version of history. To us it would be unimaginable, but to the beings in that reversed universe, time would seem normal, just running in the opposite direction. Could we ever find a way to break free from time's grip and move forward and backward at will? Time is not constant. It bends and stretches depending on how fast you move and where you are. Near a black hole, time slows down dramatically. A minute for you could be years for someone farther away. This is called gravitational time dilation, proven by Einstein's theory of relativity. If you traveled near the speed of light, time would slow for you too. A journey lasting a few years for you might be centuries for those on Earth. Could advanced civilizations use this effect to travel into the far future without aging? We feel like we live in the present moment, but does now actually exist? Some scientists believe time is just a fourth dimension, like space. That means the past, present and future all exist at once. We just experience them one moment at a time. If this is true, then time is like a book. Every page already exists, but we only read one at a time. Are we simply moving through a universe where our future is already written? If time travel were possible, could you go back and, actually change history? The grandfather paradox asks, what if you traveled back in time and stopped your grandfather from meeting your grandmother? Then you would never be born, which means, you never traveled back in time in the first place. Does this mean the past is unchangeable? Or would a new timeline split off, creating an alternate reality? Some physicists believe that every possible event creates a new timeline. If you flip a coin, there are two outcomes, heads or tails. What if both happen, but in different universes? One where the coin lands heads, one where it lands tails? Now just imagine this applies to everything. Every choice, every moment, every possibility. Each one creating a new branch of reality. If this is true, then in another universe, another version of you made a different choice. Somewhere you are living a completely different life, and somewhere else, an entirely different cosmos has unfolded. Some physicists believe we exist inside a block universe, a structure where past, present and future all exist at once. Imagine a DVD. To a character in the movie, time is flowing forward. But to someone outside the DVD, every scene already exists. It just hasn't been played yet. If we live in a block universe, then everything has already happened. Every choice you've made, every moment in history, even the end of the universe, it's all already there. We are just experiencing it one frame at a time. If time is just another dimension like space, could we learn to move through it freely? Some theories suggest exotic matter or extreme gravitational forces could let us step outside time, like moving up a level in a video game. Could a sufficiently advanced civilization figure out how to break free from time? And if they did, what would they see?